I thank everyone for coming today and attending the session called A Day in the Life of a Civil Engineer. My name is John Sayre, and I'm a technical marketing manager focusing on civil infrastructure here at Autodesk. I've been working in the civil industry for 25 years. I've been with Autodesk for 6 years, building technical assets, creating marketing videos, presenting on webinars, and being the infrastructure track manager for AU. Before I came to Autodesk, I worked 8 years for a partner in the channel covering the infrastructure products. I will be taking the civil engineer, civil designer role in this presentation. Next, I'd like to introduce David Reeves from Esri. David is a senior solutions engineer on the architecture, engineering, and construction team. He has been with Esri since 2013. David will be taking the role of the GIS analyst for this session. This is our safe harbor statement. And since I may provide forward-looking information, please note that these statements merely reflect our current plans, and these can change in the future. One of the first tasks in every infrastructure project is to gather existing conditions information for the project area. This is a very fragmented and disconnected process. Designers need to contact the relevant GIS departments, which can be difficult in itself, and maybe not knowing who they even need to contact, and then wait for days and maybe weeks to get the requested information in shapefile format. Then once they've received the shapefiles, they may not have the right coordinate system information, or they might have been given the information but not in the location they needed. Regardless of the problem, an additional request would have to be made, and the process starts all over again. Using the existing conditions data once received and the design has been finished and approved, as-builts will be generated. The owners most likely will require that they be submitted to them in a shapefile format, or even worse, in a DWG format, and they're requiring that it be exported to a specific release of DWG that is much older than the version it was generated in. Once that data is exported in any way, shape, or form, the data then becomes dead data. Meaning if a change or addition is made to the information, it has to be exported again. Changes and additions are made to GIS information daily. Wouldn't it be nice to have a live link to that data so that if the update is made, that you would get that update automatically? Unfortunately, this photo represents a lot of owners' office conditions. For example, the plans on top of the cabinets might be active projects that are going on, or they might be just plans that they've tossed on top of the cabinets because they were in a hurry and thought, someone else can file them. This is a big problem. What eventually will happen is that documentation from these projects will get damaged, project plans can get mixed together with other projects, and sometimes plan sets just simply get lost. This has been the standard forever. So what if all that data could be housed in one central location? What if this data could be made available to folks in minutes instead of days, weeks, or ever? And what if this data was live data that could continually be updated for facilities management? Autodesk embraced this challenge and formed an alliance with Esri in 2017 to transform the workflows involving GIS and BIM information. To do so, the partnership is focused on putting data at the center to allow for smarter decisions and better outcomes. From the planning, designing, and building to the operating and maintenance of infrastructure assets, bringing GIS and BIM together allows for a more frictionless live and native data workflow between platforms in order to reduce risk, inefficiencies, data loss, and cycle times. For example, by putting data at the center, teams can build more robust existing conditions models for planning, preliminary engineering, and design, and they can enable intuitive access to operational data and information for improved asset management. With the improvements introduced during the last 2.5 years, we're now able to connect GIS information into our designs straight away to refresh and update the information as many times as required during the design phases and to publish the as-built information directly into ArcGIS. In this presentation, I will take you through a workflow that will represent the day in the life of the civil engineer. First, we will talk about gathering existing conditions, the first step in every project. You need to know what the existing conditions are to start making good design decisions. Second, we will talk about utilizing the existing conditions for design. And third, we will talk about the as-built deliverable that owners need at the end of the project. Before we start though, I wanted to talk about the project we'll be working on today. This particular intersection at Santa Fe and Mineral Avenue in Littleton, Colorado has shown to be a traffic hotspot. The decision has been made to design a grade-separated interchange. This will definitely help with the traffic issues at this intersection. So as the civil engineer, I will need to start gathering all of the existing conditions that I can. I'm going to contact David, our GIS analyst, to pull all the GIS data that he can in this particular area so that we can utilize that data to help us make good design decisions. So David, give us a look at how you would do this.
As a GIS user, I can help out John by gathering as much data about our project site as possible using ArcGIS Pro. Then I can share it to ArcGIS Online or ArcGIS Enterprise as a web map, or a story map, or a dashboard, and many other options to be used by him and anyone else involved who needs this data. Now I can use ArcGIS Pro or ArcGIS Online to gather data and create a web map that can be accessed by anyone on the team, on any device, at any time, even inside of Civil 3D and Infraworks. Inside of ArcGIS Pro, I'll choose one of the included base maps to get started. Now some of the data that we're going to need is public. So I'll start by searching the county where our project is located. Here in Arapahoe County, I find lots of public data for addresses, boundaries, parcels, which I can download as static shapefiles and geodatabase feature classes. Now the city of Littleton, they also have GIS data, but they share their data straight to the ArcGIS platform, so that it can be used and even updated more easily. If we browse their gallery, things like city boundaries, parking, design standards, and even historical data can be viewed here in your browser and used immediately in your web maps. But instead of downloading these, I'm going to connect to them directly in ArcGIS Pro. Another set of data that GIS users have access to is the living atlas of the world, Azure collection of ready-to-use curated data from authoritative sources. Environmental data, infrastructure data, even demographic data and traffic data is available. Since ArcGIS Pro is a connected desktop, I can browse any data stored in my company's ArcGIS Online account. I can also search for the data that we saw from the city of Littleton. Instead of passing around static shapefiles, all I need to do is search for Littleton Rail. I can find the railroads layer and then right-click on it and add it to my current map. So that live layer stored in ArcGIS Online is now part of my map. I can also search for hydrology. I'll find the rivers, right-click on it, and add it to my map also. I'll turn on some additional layers showing street center lines, schools, and public places. You can also search the living atlas of the world and add in useful information like current and historic traffic patterns to coordinate deliveries and road closures. I'll find the layer and add it in. It'll show me red, yellow, and green areas indicating traffic congestion. Now once I feel that my map is ready, within a few clicks I can share it as a web map to ArcGIS Online. I'll determine the settings such as editing capabilities and who can access the data. Here I'm going to share it with the Santa Fe Mineral Content group. Anyone in that group can go there to find related data. Now I'll share it and we'll go look at the web map in ArcGIS Online. After I log into arcgis.com, I can browse my organization's data and even find my Santa Fe Mineral Group, which John is a member of. Anyone who is a member of that group, be it an analyst, engineer, field worker, or project manager, can use and interact with everything in that group. I'm going to open up my existing conditions web map that I just created with ArcGIS Pro to see what it would look like for John, for my field workers, and that product manager. Making sure my layers draw well and my symbology is set. Once it's ready, John can open this up in Infraworks and Civil 3D to browse and use these existing conditions.
While David was curating that great GIS data, we've been putting some things together ourselves as civil engineers. We will start here in Infraworks. We're going to use Model Builder to create our initial model. I can take a look at the aerial view to help me locate my project a little bit easier. Once I locate my project, I can add an AOI or an area of interest. Let's give the model a name of Santa Fe and Mineral Construction, and then drop down and select the coordinate system for the model. The coordinate system that we need to select for this project is CO83-CF, Colorado State Plane Central Zone Foot. All that is left to do is create the model. Once the model is created in the cloud, you will receive an email telling you that it is available for download. When you first open the model, Infoworks gives you the option to save the model in BIM 360 and or on your local drive only. If you save it to your local drive, you always have the option to publish it to BIM 360 at any time. Publishing the model to BIM 360 gives you the power to share the model with all stakeholders involved in the project. Now that we've got our model back from Model Builder, we're ready to start taking a look at some of the data that was provided by our survey department. They provided us with a point cloud in that area of the project and a high resolution image. Both of these pieces of data will help us make design decisions right out of the gate. Because the image was processed using the same coordinate system as our model, which was CO83-CF, when it comes into Infraworks, it'll place itself in the correct location automatically. The process to bring the point cloud in is really much the same as it is an image. You simply drag and drop it on the screen. And again, because the point cloud coordinate system matches the coordinate system of our model, it should fall right into the right location. We will use this point cloud to generate a surface here in Infraworks, and then ultimately be able to use this same surface inside of Civil 3D when we jump to the design phase of the project. Now that we have the point cloud in the model, I'm going to generate a surface from the entire point cloud that was provided to me. I can actually turn off the point cloud though in the model and switch to what is called my engineering view and see the surface that was provided to me from Model Builder. This surface from Model Builder is USGS information, so my point cloud data is going to be much more accurate. In the point cloud terrain dialog, you have several processing rules to choose from that can change the physical size of the surface it creates. You have the flexibility to select the settings that you only need. And in this instance, I'm going to be pulling linear features from the surface here in a bit. So if I leave the settings all to optimum, it should work great for pulling those. Now this was about a 3.2 gig point cloud, so it's going to take a little bit of time to generate the surface. Now that the surface is built, I want to take a look at the surface contours. To do that, I can open Model Explorer and then turn off the point cloud. Once the point cloud is off, I can switch to an engineering view and the contours will show up. As you can see, the surface generated from the point cloud is much more dense than the USGS information. Now that I've verified the surface, I can turn the point cloud back on in Model Explorer and get ready to run linear feature extraction. Now, why would I pull linear features? I want to create line work for all the lane markings on this road. To do this, in the past, you basically have to trace the lane markings, which is very tedious. By using linear feature extraction, Infraworks will utilize the surface that I generated from the point cloud and recognize the painted markings from that cloud. I can just select the style that I want and then pick a couple of points that are following along the painted line. Now, you might not see them out of the gate because the line that is created is basically draping itself vertically on the cloud as it moves up the road horizontally. But as you can see, in a matter of seconds, it will create a line following that painted stripe. So if I turn off my point cloud, I can then see the lines it's generated underneath. Now, I've created all the linear features in another proposal in my model. So when I switch to that proposal, I can see all of them. Simply turn the point cloud off again and they display perfectly. A couple of things we can do to see them a little bit better is to change back to the conceptual view in the model, which will turn off the display of the contours, and then turn off the display of the terrain overlay. You can see that they run all the way to the existing intersection, but then stop at the end of the markings themselves. Now I need to generate what is called transverse features from my surface. These transverse features will help me to create a lightweight surface from the point cloud without losing any accuracy that I can use inside of Civil 3D. This will make my model in Civil 3D, where I do my design, run more efficiently. Now that we're ready to create transverse features, I want to be sure that I have at least one of the linear features I generated make it past the existing intersection, because I'm going to need surface information for a ways past the intersection. In looking at the intersection on the north side, I've decided to pull an additional linear feature to represent the skip line in the far west lane, moving further north. I just used the same process as I did to generate the line south of the intersection. Only difference now is that I need to join the skip lines through the intersection. I'm going to use that skip line as my baseline for the transverse features. Again, I will turn off my point cloud because it makes it easier to see and select the lines that's been generated. To join linear features, I can simply select one of the lines that I want to join and grip edit the line across the intersection. It will prompt me to either just connect the lines or to actually merge them together. That's what I want to do. I want to merge them together. Now I'm ready to generate the transverse features. To create transverse features, I can simply select the linear feature and right-click and pick Generate Transverse Lines. In the Settings dialog, I need to give it a line length. Treat this like you're creating cross-sections. I'm going to use 120 foot so that I can be sure to get good coverage. The distance between vertices is how often across the line it will sample from the point cloud. I'm sampling every 2 feet. I could definitely sample much tighter if I needed to. Once they're done generating, I can turn off my point cloud again and take a look at the output. Notice if I pan down the road, the transverse features run through the intersection like I wanted them to. If I had not joined the lines together at the intersection, Infraworks would have stopped at the intersection. Not a problem if it happens. I could have just picked it up on the other side and been fine. But I wanted to sample it in the intersection itself. Now to export the data. I need to export the data so that I can use it in Civil 3D for my design. I'm also going to publish the striping information to ArcGIS Online so that others in my organization can have access to it for future projects. I have the option to export out ground points from the point cloud if I want to, but I only want the line work and points generated from the transverse features for my road only. Again, this will keep the size of my surface down in Civil 3D and make the model much more efficient when I'm creating the design. Now I'm going to start using the existing conditions data that I've generated in Civil 3D. First item we'll bring in is the high quality raster image provided by the surveyor. We will do this by using raster design inside of Civil 3D and part of the AEC collection. Raster design also recognizes the coordinate system embedded on the image, so it will locate itself accurately. Now, using Map 3D that is inside of Civil 3D, we can import the shapefile that Infraworks generated of the linear features. You can see that the line work and the image line up very nicely. The next step will be to create a surface from the point file that was exported from Infraworks that was made up of the transverse features. We will name the surface Transverse EG so that we know what it was built from and pick an appropriate contour style. The last step will be to add the point file. The file we generated is a CSV file that is comma delineated and represents ENZ, which stands for easting, northing, and elevation. This method of surface creation does not import the points themselves. It creates the surface by reading the file only. This helps with model efficiency also. As I mentioned earlier, I want to publish the lane striping line work to ArcGIS Online. And in order to do that, I need to create feature lines from the line work that was brought in from the shapefile. So to make it easier to see, I'll turn off all the other data so I can easily see the lines and select them all at once. I also want to add some attribute data to the line work that will get published also. We will do that by adding what is called property set data to the line work. In Civil 3D, you have the ability to create property set data. This allows you to create attributes and apply them to entities inside of Civil 3D. These attributes will then get published to ArcGIS Online with the line work. I have created a new property set definition called lane markings. I will define the civil objects that the property set information applies to as feature lines. That's the type of civil objects that represent the lane markings in my model. If I want, I can apply it to multiple types of objects. The next step would be to add the definitions to the property set. This is the actual attributes I want to apply to the lane markings. For this example, I will add an attribute for the last paint date, the paint crew, the color of the paint, and the type of paint used. I will select Apply and OK, and now I'm ready to add the attributes to my line work. First, I will open the Properties dialog box. I want to add the property set data to all of the lane markings at once, so I can select one of the markings and right-click and pick Select Similar, and all of the lane markings will highlight. If I go to the Extended tab, I can select Add Property Sets, and it will add them to all of the entities. For this example, I'm going to apply the same attribute information to all the markings, knowing that I will have to change the color of the lanes shortly. The next step will be to publish this data to ArcGIS Online. After connecting back to this data from ArcGIS, I will show you how to modify the attributes. We will definitely be able to take advantage of the lane markings as existing conditions data for our project, but I really need to make it available for everyone to use and have access to for any future projects in this area, or even use it for scheduling maintenance in the future. To do this, I can use the Publish to ArcGIS feature that is inside of Civil 3D. This feature allows me to connect to ArcGIS Online and publish civil objects and the property set data that we applied. When I publish the data, I have the option to publish all of the attributes, or I can select the attributes I want to publish. I might have sensitive data that I don't want to be made public, so I can deselect those attributes and it will not publish. This gives me the flexibility to only share what I want. When naming the file, you want to be sure that you replace any spaces you have in the name with an underscore. If you don't do this, then you will get an error and you will not be able to move forward with the publish. You will also be asked to add a tag so that it is easily searchable inside of ArcGIS Online. This is also mandatory to move forward. I have the option to set this data to be editable or non-editable. I want it to be editable in this example because after we bring this data back in from ArcGIS Online, I want to show you how we can edit the data and do what is called a save back. Once the data has been published, you can select View in ArcGIS and instantly view it inside of ArcGIS Online. Publishing the data from Civil 3D has created a new feature layer inside of ArcGIS. We can navigate to the line work and pick one of the lines and see that the extended attributes we added as property sets in Civil 3D have also been published. Now, let's go back to Civil 3D and talk about the Save Back feature. The line work that represents the lane markings in my Civil 3D model is still in my existing conditions model, but it is not directly connected to ArcGIS Online. So if I was to change an attribute now, it would not update ArcGIS Online. So I will delete the lane markings and connect to the data I published in ArcGIS so that I will have a live connection to the data. Then if I make a change to the data in Civil 3D, I can perform a save back and it will update in ArcGIS Online. So if other folks are connected to the same data, they will get the updates, and if others update the data, I will get the updates. When I connect to ArcGIS Online to bring in data, I simply navigate to the city my project is in and set an AOI, or area of interest. If you remember, I published this data to a specific group, so I can narrow down the search for what I want to import by selecting my groups and then select the specific group it resides in. I can search for the tag that I added and it narrows it down even further. Once I select the feature layer, I need to pick what type of feature I want to represent the lines in Civil 3D. In this case, I want them to be feature lines. I can select the eyeball and it will give me a preview of the feature layer before I add it to my project. Now, the data looks just like the data we erased, but there is one big difference. If I take a look at the properties of one of the lane markings, the attribute data shows up. I can see from the high quality image below that some of the lane marking attributes say the color is yellow. And I can see from the image that they are actually white. We can simply change the attribute here in Civil 3D, and then when we do a save back, it will update the information in ArcGIS Online. In this example, I'm just updating one attribute, but we could update all of the attributes if we needed to. Now that we have made the changes, the next step would be to save back. In the Data Source Manager, you simply be sure that the feature is selected that you want to save back, and then simply select Save Back. If we go back to ArcGIS Online and select one of the lines, you will be able to see the change we made to the attributes in Civil 3D. Remember, everyone that is connected to this data will get this particular update. Now that we have pulled together and shared with others some of the existing conditions data, we can turn our focus on what David was able to pull together for us. Using the connector for ArcGIS, we can connect to the data just like we did with the lane markings. And again, what this will do for us is create that live link to the GIS data so that if it gets updated, we can see that update. In the past, I would have had to find shape files from multiple different sites or make several different phone calls to governing authorities to get data, and then place them on my drive and import them into my model, which at that point, the data is dead data. meaning if the sources update their one piece of data, I would not get the update unless they sent me a new updated file. David has found additional information to the west of our project that is a new development that might actually impact our roadway project. David was able to find several different types of data in his search that includes center lines of the road for Littleton, the Littleton trail system, and the rail system in Littleton, which could be impacted by the new design. Also in his search, he found several different utilities such as sanitary sewer and potable water. If any of these utilities need to be relocated during the design process, it would be good to know now at the beginning of the design and not during construction. David has found additional information to the west of our project that is new development that might actually impact our roadway project. Because this workflow that we've been going through was used, all of the design and as-built information for this project has been added to ArcGIS Online and is available for consumption. As you can see, there's a wealth of data for that project, including sanitary sewer, potable water, and stormwater locations, and one feature layer that you might not have thought about, that would be existing trees. This is a newly developed project and has a lot of new landscaping. And if we need to purchase additional right-of-way for this project, this could impact those tree locations for sure. When you bring in utilities like sewer and stormwater, you can have Civil 3D generate pipe networks from the GIS information and apply the attributes from the GIS data to the network for things like pipe inverts, pipe length, and slope, for example. This will allow me to quickly adjust any of those types of utilities using the dynamic functionality in Civil 3D if there are conflicts with the new roadway design. After the import is finished, we can start to focus and use the GIS data to start making design decisions. Now that our design is completed and approved, our model can be brought back into Infoworks for visualization and to help convey to all stakeholders how the design will look once constructed. To take things a step further, once an as-built has been completed for the project, the model can then be pushed out to GIS so that you have the most accurate information available. Because we saved and housed all of our design files in BIM 360, the ability to take this data to ArcGIS Pro has been streamlined. Now David can access BIM 360 directly and start to curate this accurate data simply by giving him access to the project in BIM 360. Being able to see the final design in a 3D contextual environment allows all stakeholders to get a look and feel for how the project will impact the existing conditions around the project. Here in Infraworks, we can access all of our design files for this roadway project through BIM 360 and bring them directly in to our 3D model. This representation of the design in the 3D model will help to answer questions that might come up about the design project. Once the design file has been connected as a data source, you will have access to the design corridor that was generated in Civil 3D. In this example, I've selected the design file in BIM 360 that I showed you earlier, and we can take a look at the configuration dialog once it comes up. In road options, we want to be sure in this case that this will be using the corridor component road settings. But we can drill down further and change materials of the corridor to match how we would like it to be represented in our model. I am happy with just using the default settings for now, so I will select Close and Refresh, and Infraworks will access BIM 360 and bring in our design from the Civil 3D model. After the import is complete and the model has regenerated, you will see the proposed design in your 3D contextual model. Having an accurate 3D representation of the roadway project design is one of the best communication tools you can have. Now we will turn it back over to David and let him show us what he can do with not only our design data, but the as-built information that he has been given access to in BIM 360.
Right now, ArcGIS Online and BIM 360 are storing and sharing tons of valuable project data. John showed us how the Autodesk Connector for ArcGIS can be used to bring GIS data into Civil 3D and Infraworks. He's able to edit and save back to the GIS system of record. Now, I'm going to bring those final designs from Civil 3D into my GIS software so that the GIS team can use it for asset management, comparing with construction progress, and digital project deliverables. To do that, I'm going to take advantage of brand new functionality in ArcGIS Pro, our desktop software, that allows me to connect to all of the data stored in BIM 360. In ArcGIS Pro 2.6, I can create a connection using my Autodesk credentials and browse project files and designs. Instead of emailing files or using a network drive, I can download a DWG or Revit model and add it to my 2D or 3D map alongside all of my GIS data. This allows you to collaborate with other teams working with the same data outside of the ArcGIS platform. To create a connection in ArcGIS Pro 2.6, you add it like a connection to a server or database. I'll choose to insert a new BIM Cloud connection. I'll give it a name, and after I hit OK, I'll provide my Autodesk username and password. After I've done that, the connection appears in my catalog pane on the right, just as if it's a folder in my computer with data inside of it. I'll expand that connection and I can see actually all of the BIM 360 projects that I've been given access to. I'll explore our Santa Fe mineral, and the data I need is inside of this civil folder here. So one of the things I'm going to do is choose to add the manifest of that folder to my project. Now what that'll do is allow ArcGIS Pro to go and check BIM 360 for updates to any of these drawings in this folder. Now the data I need is this final design. So I'll choose to download it and add it to my project. After that DWG has been downloaded, I can see it in my project folder, and I can add the entire thing to my map. It was drawn in its real world location, so it should line up right with the roadway in my base map. There I can see everything from that Civil 3D drawing. I can see annotations, points, lines, polygons, multi-patch features, everything. Now, I would just like to look at the line, so I'm going to remove all those layers and just add in the line features from my final design. So now I can see my final design drawing in its real world location, and from here I can do things like add GIS data to it. In addition to 2D features, I can also bring in three-dimensional features from my Civil 3D drawing. Here I can see that final design drawing in its real world location and in 3 dimensions. I can pan around the design and even look at the existing GIS data alongside it. I can see this manhole down here at the bottom, and if I navigate underground, I can also see the underground water and sewer lines provided to me via GIS. This gives us valuable data about what's on my construction site and what's underneath it. From here, I can begin managing my assets. Right? I can see my existing conditions and my final design. I can manage my construction assets coming up. I can define laydown areas even. And if I combine this with drone flights, then I can monitor progress remotely and even do things like plan street closures and deliveries, communicating in a way that's easy to understand for all project stakeholders, especially non-GIS users. After securely logging in to ArcGIS Online, I can start browsing these web maps, right, for non-GIS users, for stakeholders, project managers. I can interact with the data, I can query it, I can click on it, I can get pop-ups, and I can use these data sets to create some focused applications for my project. We're going to have to deal with some road closures and detours, and so this application allows non-GIS users to define roadblocks, closures, and detours. I can enter in the road closure, specify the street name, give it a reason, description, start time, end time, and save my results. Now, this information can be communicated not only to internal project stakeholders, but also external ones also, right? The public can be made notified of these closures, these roadblocks, and these alternate routes. The existing conditions can also be visualized in 3D as well. Right? All of these maps and apps that you're seeing me interact with require no development and coding. We can have a simple 3D app to interact with our site, or we can turn it into a dashboard, right? Filling these widgets with charts, meters, lists, and anything else that could help us make decisions about our project site. All of these maps, apps, and data sets can be combined together into a hub. Using Arcgis Hub, you can gather together all project data, materials, schedules, events, feedback surveys, combine it all into one place for internal or external project stakeholders to go to so they can evaluate existing conditions, download project data sets, and just view progress through completion.
In summary, when looking through the lens of the day in the life of a civil engineer, gathering existing conditions is always the first step in all projects. We were able to combine the surface information from the point cloud data, capture linear features from the point cloud in Infraworks, and then publish that data to ArcGIS Online for other use on existing or future projects. We leaned on our GIS analyst, David, to go out and curate as much existing data in the area of our project he could find, and he came back with a lot of great data that we could add to our model and start making design decisions. After our design was finished, we showed how we can bring the Civil 3D design model into Infraworks and create a compelling visualization to be used to better understand the project by all stakeholders. We then handed it back over to David, where he connected to BIM 360 and took our design and as-built information into ArcGIS Pro and ArcGIS Online so others could get access to the most accurate data available in the area. I thank you for taking the time to attend this session and hope you have a great rest of the day.